Hey folk blog, this video is meant for you because I'm not going to be here on folk blog today. So with that in mind, we're going to go over a couple of notes. You will have to do your independent practice. After that, it's going to be a free class for you, pretty much. So for today's note, we're going to go over what is a monomial, binomial, and trinomial. Monomial basically saying that you're going to have one term and one term only. You will not have any adding, subtracting between them. As you can see here, I have a couple of examples. X, Y, or just X times Y. This is perfectly fine as a monomial. If you take any Spanish class, you will realize that mono means one. Second of all, it's going to be binomial. Bi means two. So for binomial, you're going to have two terms. They will be separate by an adding or subtracting between them. For instance, the most popular one going to be x plus y. Less popular going to be x plus z. You're going to have something really crazy with this. For instance, 2x squared plus 5. You can have something like that. It's perfectly fine. Well, last but not least, going to be trinomial. Again, tri means 3. You should expect to have 3 terms. Each term going to be separated by an adding or subtracting between them. For instance, x plus y plus z. Or you can have something like x squared plus 2x plus 4. We see this term a lot, especially in math 2. Alright, so in this case, let's try identify some key feature in here. Coefficient, degree, constants. We did this multiple times during first week, second week, and third week. Leading coefficient, if you have no idea what leading coefficient is, leading means it's going to be in front. It's going to be the one in front of everything. So coefficient meaning that it's going to be a number. Coefficient is the number in front of a letter. For instance, in this case, 5 will be my leading coefficient. Because 5 is a coefficient of x cubed, also 5 is the one that in front of everything. How about the constant? Well, if you look at this one here, constant should be a number without any letter next to it. So for this case here, a constant should be positive 29. Notice that I bring the sign with that. Let's do something a little bit harder. Let's try to find a degree. So the degree of the function will always going to be the highest degree in the whole thing. So in this case here, the degree of the first term you have will be 3. Degree of the second term is 2. Third term is 1 because there's nothing there. You have to assume it's 1 in there. And the last one, you have no degree whatsoever. So the degree of a function in this case should be 3. So next part, I want you to spend 5 minutes to work on these things. You can pause the video for those. I'll wait. Okay, so I assume that you pause the video and try your best on this case. So the answer of this, same concept, we need to find a leading coefficient first. And leading coefficient is the number in front of everything. So in this case, you may say that the leading coefficient is 2, but it's not true. Why? Because this function here is not in the right order. Every time you have a function, it has to follow that the highest power is the one in front. Therefore, you should move the 6x to the 4th power first before you do anything here. So let me go ahead and move that for you. Alright, so after you move that, we can say that the leading coefficient in this case should be -6 because that's the leading number. Also, x to the 4th power is the highest power of all. How about a constant? Well, constant in this case should be +4 because that's the number, the only number without any letter next to it. The degree of your function will be, since the highest degree we see here is 4, therefore the degree of the whole function here has to be 4. Similar concept. Let's make something a little bit harder. The A, B, C thing here. No worries. Every time you see something fancy like this, you have to understand that your A, your B, and your C can be any number. Any number that you desire. That's what your A, B, and C represent. So same concept, we have to make sure that they're in the right order first. Let's see, we got x to the 2nd power, x, no x, which is checked out. So in this case, the leading coefficients, it should be letter A, whatever your leading coefficient will be. Your constant, let's see, constant will be a number. In this case, has to be a letters without any x's. So it should be C. Last but not least, going to be your degree. In this case, should be 2 because that's the highest degree you have in here. Now let's move on to number 3 here. Feel free to pause this video and try by yourself before you actually see how I do this thing. I'll wait. Alright, so I assume that you try it by yourself. Let's go over this. For your first function here, that's not in the right order. Well, how do I know that? Well, because 2nd power is the highest power in this case. Therefore, this thing has to be the one in front. So now I'm going to reorganize this. Let's see. The highest power in front, x squared. Second highest, which is 2x here. Last one should be just 4. Is it in standard form? Question mark? Well, quick recall here. So you can see that. Recall. standard form, meaning the highest power has to be in the front. And then it has to decay, and then the next term has to be decay from the, for instance, we have here x squared, x, no x. All right. So in this case, the standard form will be x squared, 2x, and 4. What is the degree of this function here? Well, like I said before, degree should be the highest power in the whole functions. Most of the time, you can find your degree based on the leading term. So here we'll put the x squared in front of everything. So that has the degree of that has to be 2, because that x squared means 2. The leading coefficients. Well, since we have nothing here, we have to assume that the leading coefficient is 1. Really critical part. Constant term in this case, -4. What kind of classification here? Well, let's see. Classification, since we have 3 terms, 1, 2, 3. Classification of this has to be a trinomial, a tri. Same concept. So you got square root of 3x squared. Is that in standard form? Yes, because it's only 1 by itself. What's the degree of this? This has to be 2. Leading coefficients. Well, since they only square root of 3 in front of this, your leading coefficient has to be square root of 3. Really clear. Constant term. Do we have any constant? Obviously, no. Or you can say NA if you want to be fancy. We'll just do NA. Classifications. Well, since you only have 1 term and 1 term only, has to be monomial. Similarly, on the next one, 5x is 7 plus 6 plus 3x is 9. It doesn't seem right at all, because the highest power in the back, you have to bring it into the front. So in this case here, it has to be 3x9 in front. The second highest power, which is 5x7. And then the 6 in the end. The degree of this case will be 9, because that's the highest power you have in here. Leading coefficient, 3, because this is the one in front. Constant term, 6. Classification, 1 term, 2 term, 3 term. Has to be your tri. The last one kind of tricky here. If you don't remember this, back in Math 1, we do something called degree. Basically saying that every time you have something crazy like 3x squared, y3, and you wish to find the degree of that, well, all you have to do is just add the degree together. So in this case here, the degree of this fancy term here has to be 2 plus 3, which is going to be 5. So the degree of this is 5. The degree of these two has to be 2. The degree of these has to be 3. Obviously, this thing has to be in front. So we reorganize those. 3x2, y2, y3, plus 2x y squared plus xy. The degree of this, since this is the highest degree, it has to be 5. Linear coefficients has to be 3, because 3 in front of everything. Do we have any constant term? No. Since we have every single term in here involving with letters, there's no way you're gonna have the constant term. So NA in this case. Classifications. 1 term, 2 term, 3 term. Has to be a trie. Let's conclude the first part.